Hello boys and girls, welcome back to another lesson in algebra. This is Mr. Bean, and today we're going to be talking about exponential decay. But before we jump into that, let's remind ourselves some things that Mr. Sullivan taught us in the last unit. When we had a sequence and we started with this number 12, when we started off and we go to the next number 24, 48, you had to figure out that this was a geometric sequence because we were multiplying by the number 2 over and over. So if you remember that, we'd say something like a of n equals, our first number was a 12, and then we'd have a base of multiplying by 2 because we were doubling over and over and over. And then up here we had an exponent of n minus 1. That was kind of tricky. We had to have an n minus 1 because that was our first number. We haven't done that yet in this unit. We will get a little bit more into this n minus 1 stuff. If you look down here, we've been only having just one single variable, no minus or plus at the beginning. Don't get too worried about that yet. We'll talk more about that in the next lesson. But this one, if you see the sequence of numbers, we start with 12 and then we're going down by 6, down by 3, down by 1.5. That's because you're dividing by 2 each time. Or in other words, we're multiplying by 1/2 in order to get from one to the next. So the way we write that explicit equation is we would say a sub n starting with the number 12, and then our base of our exponent would have been a 1/2 raised to the n minus 1. Okay, so why am I bringing this up? It's because last lesson, we talked about exponential growth when the numbers were getting bigger and bigger and bigger. And in today's lesson, we're going to focus a bit more on the numbers getting smaller when we're multiplying by a number that's less than 1. So that brings us to some definition part here. If this b here, the base of our exponent, if that number is larger than 1, then we are growing. It's an exponential growth. If the b is less than 1 but greater than 0, so we got to be in between 0 and 1, that means our value is decaying and getting smaller and smaller. Just like this 12 up here, we're taking half, 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 half. It's getting smaller and smaller and smaller. Never actually gets to 0, but it does get infinitesimally smaller and smaller. So get that written down if you don't in your notes. Extremely important for what we're doing today, distinguishing between growth and decay. So here's our first examples. Is this number 1, is this representing exponential growth or exponential decay? All you have to do is focus in here on the 3/5, and that 3/5 is smaller than 1, so we're going to say that it's exponential decay. And then the way we justify, see here it says justify your response, is we're going to say that the letter b, the base, is going to be in between 0 and 1. That's our justification. Next example. So again, here's our example. You want to get that written down. F of x equals 2 times 7/5 raised to the x. We're using function notation, but hopefully that's not throwing you off at all. And that here is our b. And is that greater than 1 or less than 1? 7 divided by 5 is going to be larger than 1, so it is exponential growth because b is greater than 1. Next problem, f of x is equal to 4/3 times 1/6 x. So here's our base, 1/6. That is smaller than 1. So, oops, not growth. This is decay. It's getting smaller and smaller. So it's because b is in between 0 and 1. So we just put a little less than in between those. And our last problem set here is that 4/3 is the base. So you got to write this out, 1/5 times 4/3 raised to the x. That is going to be 4 divided by 3 is larger than 1. So that puppy is growth. And we say our justification is because b is greater than 1. That's why it's growth. So again, the a in every single one of these does not matter. It's only the b, the base of the exponent, that tells you if it's exponential growth or decay. Now your favorite part, we're going to graph. Oh, I know you love this thing. We're going to just start off with the same things we did in the last lesson. That is, let's just use really easy 0, 1, and 2. Usually that's enough. I'm going to put that on both of them, 0, 1, and 2. In fact, on this one, I already tried this out. I'm going to go one more on this one. Okay, so how do we do this? We start with 15 and we multiply it by 1/3. Sometimes they're easy enough to do in your head. Sometimes you're going to need to grab a calculator. So 15 times 1/3, just let me write this down here so you know. That's exactly the same thing as just saying 15 divided by 3. It's the same thing as multiplying by 1/3. 15 divided by 3 is 5. Oh, wait, I did that wrong. Hold on, forget what I just said. Let's do that again. We have to first plug in the 0 into x. So when we plug a 0 in here, this whole thing becomes the number 1. 1 times 15 is 15, because the initial amount, we're starting at 15, so that's our first y value. Now we're going to plug in a 1, which means 15 times a third, or in other words, 15 divided by 3. That's when we do this. That's the 5 there. And then we're going to multiply by 1/3 one more time, which is 5/3, or in other words, that's 1.67. Because I already checked on my calculator. Okay, let's plot these points. My graph only goes up to 10 lines, so we're going to have to count by 2s in this case. So I'm going to label this 2, 4, 6, 8, 10, 12, 14, 16, and now that's far enough because now I can plot the 15. So 15 will be right there in between. 1, I can count by 1s here, that's fine. So 1, 5 would be here, and 2, 5/3, 1.16. Where in the world? 1.67. So 2 and 1.67, somewhere right around there. So you can see this is a pretty steep line. Now the trick is for me to be able to graph a curve, and something like this, with the arrow going up. And here it's going to curve pretty sharply. It's not a corner, but it will curve, and it's going to be approaching this x-axis here. So it will never ever get to 0. It won't actually touch the x-axis, but it's going to get awfully close. Just like, let me go back here and review something that we did earlier. Whoops, not that. This one. On the very beginning when we did the recall of decaying here by a half, we took half and got smaller and smaller and smaller. Think about how these numbers will never actually get to 0. They just get really, really small. The same thing is happening with your graph, and that is that these numbers are going to get really, really small and approach the x-axis. Let's try the next one here. 10 and 0.45. So I already did this in my calculator here. Let's see. First number is going to be a 10. If I plug in a 0 here, it gives me a 10. Then a 1 is going to be 4.5. Multiply it by 0.45 again, and you get 2.025. Now that makes sense because 0.5 would be taking it in half. 0.45 is making it a little bit more than half. So it goes from 10, instead of going from 10 to 5, it's going to 10 and then a little bit past 5. And then half of that's a little bit more. Some of you will understand what I just said. Some of you are like, what the heck did you just say? Okay, it's not that important yet. What's this next one? If I multiply by 0.45 again, I get about 0.91. Okay. 0, 10. That's way up here. And then 1 and 4.5. 1, 2, 3, 4.5-ish. And then 1, that's pretty much 2, 2.02. And then 3 and 0.91, almost to 1, right about there. So again, you can see this thing is curving as you move off to the left. It curves, and if going really high, and then this, let's see how well I can do. Oh man, that's hard to do with a pin. And then this thing again, it's going to be curving and getting closer and closer to the x-axis, curving off that direction. That's how you graph these. So again, it's just like we did last lesson. You're plugging in some points, giving yourself some dots, and understanding the shape. You will have to be able to distinguish between the two, and we'll do that a little bit more in the next lesson. This we've done before. You remember how you're just trying to figure out what you multiply by to get to the next number over and over again. So let's just start off with our equation. Y equals, initial amount is 4. So when x is 0, we start off with 4. And then I'm going to have some factor here that goes down on the base. What is it that goes here? It's hard to know exactly what I'm dividing by, so let's try going the other way. If we go this way, I'm going to be dividing by something. So I'll take my calculator, and I'm going to say in my calculator 2.4 divided by 4, and when I plug that in, I get 0.6. So this is 0.6 that I'm multiplying going to the right. 0.6 multiplied by 0.6. So that is my base, and this is decaying. It's because it's less than 1, which makes sense because I started with 4 and gets smaller, smaller, smaller. Next up, let's review a little bit from our last lesson, and that was when we added a particular percent increase to an initial value here. Let me see, what do I want? Okay, so what in the world is the percent increase that we had? If we know this is over the number 1, so if we're over the number 1, we have to have 1 plus my r, and that's going to equal 1.138. So then if I want to solve for r and subtract 1 from both sides, I would end up with 0.138. Now, move the decimal 2 times, and then my answer would be, I'll write it over here, my answer would be 13.8% increase. And then the same thing here. So if my 1 plus my growth rate is going to be equal to 2.65, then if I solve for r and subtract 1 from both sides, I would get 1.65. Move the decimal 2 places over, and then there's your percent increase. It'll end up being a 165% increase. We're going to do the same thing today with a percent decrease, except that instead of saying we're going to do 1 plus the percent increase, this will be a 1 minus the percent decrease. I'm still going to refer to this part of it right here as the letter r, because it's going to represent the rate at which it's increasing or decreasing. But we have to convert it to decimals. Okay, so just 1 minus the percent decrease. Let's see how that works. So for our first one, go ahead and write this problem down. I know I didn't put them on there for you, but just kind of do this quickly. And our first one, our initial value is 0.5. That's pretty quick and easy. And this one, because 1.2 is bigger than 1, that means this is going to grow. We're multiplying it by a number bigger than 1, so it's getting bigger. So what we'll say is that this is I'm going to circle this right away. I know it's a percent increase. And then I'll write that it's 1 plus my rate, 1 plus r, is equal to 1.2. Now if I solve for r, subtract 1 from both sides, I get 0.2. And we're going to move this decimal place 2 places. So I'm just going to put some zeros after this just so we can see it. If I move the decimal 2 places, then we end up with 20. So we have 20%. It's a 20% increase. Okay, this one. Next, f of x equals 2 times 0.7 the x. My initial value is 2. This is below the number 1, so it must be decreasing. It's getting smaller, so I'll circle this right here. Remind myself it is a percent decrease. So now what I do is I say 1 minus an r is going to equal 0.7. Now when I solve for r, this is a little bit different. I'm going to subtract the 1, and I'm going to end up with negative r equals, so 0.7 minus 1 is negative 0.3 when I subtract the 1 this time. So then I divide both sides by the negative, and I get r equals 0.3. Now when I move the decimal 2 places, 1, 2, so I'll put a little 0 there. Now that is 30%. Oops, let's switch my colors. There we go. Okay, so let's think about this for just a second. If I look at 1.2, that's 20% above the number 1. It's a 20% increase. When I look at 0.7, that is 30% below the number 1. Therefore, it is a 30% decrease. Okay, see how those connect? If I take a 0.7, a 70%, really that's 0.7 is 70%, and a 30%, it'll add up to 100%. So when you think through that a little bit here, that might be a little confusing. Let's try another one. All right, 4. My initial value is 4. And let's say, is this bigger than 1 or smaller than 1? That's definitely smaller than 1, way smaller than 1. So 1 minus some some percent decrease is going to equal 0.025. Now when I subtract 1 from both sides, I'll have negative r equals negative 0.975. Divide both sides by negative, and the negative disappears. I'm running out of room here, so I'll squeeze it in so I'm not skipping any steps. R equals 0.975. Now I'm going to take this decimal and move it 1, 2, so I can go to a percent. So it is a percent decrease. Why is it decrease? Because the factor here, the b, the base, is smaller than 1. And then I say 97.5. 97.5% decrease. So if we take this 97.5 and this 2.5%, if you thought about this as a percent, it'll add up to 100%. Okay, last one. Initial value is 0.15, And is it above 1 or less than 1? This is above 1, so this is a percent increase where I start off with 1 plus r equals the 2.805. Solve for r by subtracting 1. 1.805. Move the decimal 2 places over, and then you end up with 80. Oh, I did that wrong. Erase. 180, as I move the decimal twice, 180.5%. And what was it, an increase or decrease? It is an increase. Okay, for the final part of the notes, let's put it all together with some word problems. So, Mr. Bean's yard is getting overrun with weeds. First year he bought his home, there was 1,800 square feet of grass. G. This little g here is just going to tell us what our variable is. It is decreasing, here's the key word, decreasing by 28.1% per year t. T is like time per year. All right, so this g and t just helps us figure out what we're going to do for our variables. We're going to say g of t equals, okay, so now what do we do here? We're going to be decreasing. The initial amount is 1,800. And then I'm going to have a parentheses, close the parentheses, raised to t. My variable t is time, it's my exponent. So if it's decreasing, I start with a number 1 and I subtract something. What am I subtracting? 28.1%. So I got to change this percent. So my next line down, g of t equals 1,800, and then it's 1 minus, get rid of the percent and change it to a decimal. That's going to be 0.281 raised to the t. So my final answer here is that the grass, with respect to time, that's going to be left is 1,800 times. Now, you can use a calculator on this. Do not be afraid of using a calculator. That is 0.1 minus 0.281. 719. 0.719 raised to the t. So there's nothing else to solve here. It just said to come up with an equation. So that is my final answer, and I'm going to box. Whoa, that's a circle. There's a square, rectangle. Box that thing. There's my answer. Okay, 15. We're going to set up a scenario, and we're going to use it to solve. So how do we do this one? We're starting off with a car. This is the initial amount right here. So there's my A. But then the key word here is that it is decreasing by 10% per year. So let's set that up. My variables are V and T. So the value of the car with respect to T here with time, V of T is going to equal $20,000. And then it is 1 minus the 10%. So instead of 10%, I'm just going to move the decimal over 2 places, and that's a 0.1 raised to the t. So I am skipping the step where I wrote this out on the last problem, 28.1%. Instead of writing 10%, I'm just going to go ahead and move the decimal 2 places right now. All right, so now I have V of t is equal to 20,000. 1 minus 0.1 is going to be 0.9 raised to the t. Okay, so there's one of my answers. There's my scenario. Now, how do I figure out how to estimate it at 4 years? This is where function notation's really nice. I love this. V of 4. That tells you that when the time is 4, it tells you what the value is. So V of 4 equals, now we just have to plug this in. Let's grab my calculator. Okay, so here, let's plug this in. 20,000, 20,000, 20,000. Yes. And then we're going to multiply it by 0.9 raised. Here's the caret button. See this thing right here? I'm going to hold that button down so you can see it. That is a caret. It raises up into the exponent. I've noticed some kids have had problems knowing where that is. And then we just say to the 4th year. So 0.9 raised to the 4th. Enter that puppy, and we get 13,122. And that's in dollars. Okay, here we go. $13,122. All right, there's our answer for that. So we have kind of like we have 2 answers for this type of a problem. We have where we had to come up with the function itself, the model, and then we had to evaluate it at 4 years. So there was 2 different answers. Okay, number 16. I want you to try this one on your own. You're going to come up with the model, kind of like this answer here, and then you'll estimate it using your model at 5 years. What's the value of the motorcycle? So try that one on your own. Pause this video. And there's your answer, $4,683, and I rounded to 7 cents. So the trick here was just to make sure the 15.7% that you move that decimal 2 places over, and you're doing 1 minus that number. And that's the last problem. We are done. I will see you back in the next lesson where we're going to talk about the difference between linear and exponential growth and comparing the two and coming up with all these cool equations like this. All right, rock that mastery check. We'll see you back in the next one.